right now all of the home automation projects use their own proprietary hardware and software, and you can't really mix and match. And so you can buy like a smart bulb or like a smart lamp, but then you have to have like the Philips app or something like that, or like the Nest is another big one. And so what we were trying to do is we were just trying to make a box that you could use. It just has its own circuits that you can plug anything into, and then from there you can turn it on or off. And so there's nothing special about these lights. These are just regular lights plugged into a regular switch. What we have in here is just a circuit that we'll talk about a little bit if you want to see.
Nice box.
Yes.
Got the Yun.
So Sam, do you want to talk a little about why we chose the Yun?
Yeah. Well, we had lots of chips to choose from. We had a whole variety of Arduinos, and the only one that compared really was the Raspberry Pi. We chose the Yun because it has everything we need, and it's an Arduino. It has the Linux side, which has the Wi-Fi and Ethernet control, and it's easy to connect, and it has the built-in REST API. The built-in REST API was, it was super easy compared to building it ourselves. We could have built it ourselves. We've done all that. We did all that in Advanced Networks, but it had that, and it would be easier to build the final product around, like with something that's not the Yun, but cheaper and compactable. The Raspberry Pi had digital circuits, and you would have to code everything. It had digital pins, but you'd have to code everything for that. That's what Alex did, and that's most of it. Do you have any questions on it?
So you're saying that your triac resistor didn't get too hot?
Yes, we stress tested it. Randy was going to talk about the circuit
Okay.
in a little bit because he was the one who soldered that.
But the unit itself?
The unit itself is the thing that gets the hottest, but not enough to cause any damage.
Doesn't start the box on fire.
No. And it doesn't melt the breadboard that it's on. So we came up with like a circuit, which is how we're actually toggling the switches. Basically, we wanted a way to toggle the AC power on and off. And so Randy will talk about that.
Yeah. Can you scroll down the thing just a
Yeah.
teensy bit so you can see the diagram? Yeah. That's one iteration of the circuit. That circuit right there will use DC power to toggle AC power on and off. So in that box over there, we have 3 of those circuits, all linked to the same power in and power out. And each circuit is controlled individually by one of the power out pins on the Arduino. You can see there basically how it works. The battery symbol on the diagram is where the Arduino actually is in the circuit, and we just use the app to toggle the power pin to turn on. It gives DC power to the triac, which allows the AC power to go through. When we turn that off from the app, then it closes the triac and turns off the light. So each iteration of that circuit that we have in that box controls one of the extension cords.
So 3 triacs.
Yes.
How expensive are those?
Very, very cheap. It was like $8 for like 5 of them.
It was less than that. I mean,
It was
maybe
ridiculously
$1
cheap.
triac. And I think that was because we didn't get them the cheapest place. We got them the place that would get them to us the fastest.
Yeah,
That's not an expensive part of the circuit.
not at all. And those triacs were way better than what we actually needed for this project, which is part of why they don't get hot. So
Yeah, so basically we're just using the triac to flip the AC voltage
Mhm.
using the DC voltage from the Arduino. So our overall product is we have something that works, and we're happy with the way it turned out. It's definitely a prototype, and there's definitely room for improvement. Right now, the app itself is directly sending a signal to the Arduino. Ideally, what we would like is for the server to communicate with Arduino instead of the app directly, and so kind of go through the server using that as a middleware. Because right now, one of the shortcomings of this project is that the app and the Arduino, they have to be on the same wireless network in order to communicate with each other. What we're doing for this presentation is we actually brought a router, and so that's how we're setting everything up. And so the phone and the Arduino are on the same network. Ideally, if we had the server communicating with it, then as long as the server and the Arduino were on the same network, you could access it from anywhere. The downside of that is there are like security concerns, because anyone who could access the server could then access your switch. And so
We would-
right now the consequences are fairly harmless, just someone else could mess with your lights. But if you use this for something more important, maybe like your home security system or even your like AC or heat or something like that, that is more subject to abuse. So right now we're handling that security problem by you have to log into the router, and so we figure if you're trusted enough to be on the home network, you're trusted enough to automate the home. But later down, if this was to be implemented, we'd probably put some sort of server and then have some sort of secure login.
Hmm.
REST API actually has some built-in security, and we just haven't used that yet. It's not too hard to integrate, but
So,
Yeah.
is the Yun, is it wireless? Does it have Wi-Fi?
Yes, the
Yes.
Yun has Wi-Fi built in.
Oh, okay, so that's how you're working through it.
Right.
Yeah.
Okay.
Again, if we were trying to scale this down to something cheaper, we'd probably use something smaller than a Yun.
But the Wi-Fi makes it a little more convenient.
Convenient, yes.
Fewer wires. And what about the app? Is it native?
The app is not native. It is a web app, which means that you can use it from your computer. You can pull it up and use it from there. Basically, anything that has a web browser will be able to use this app. And we took that approach because you don't need like the specific hardware controls that a native app would use. Because you can do everything with JavaScript, it is more convenient just to be able to access it from anywhere. It's kind of a pain to type in all the information to add a switch on a small keyboard, and so I find myself adding them like on my computer, and then it'll just show up on the phone.
But when this goes into production, you'll have an app. Well, if your users will want to have something.
If
We
they
could-
really want an app, we'd probably just do something like Cordova, where it's not
That's what I was
difficult
about to say.
to do. I mean, there's nothing here that needs more than that.
The hardware. Yeah.
Right. It's fast enough. The only performance bottlenecks are network based, not hardware based.
That's good. So the most difficult part?
I would say software wise, the most difficult part was getting a server on the Arduino that did what we wanted it to do. They have their own language. It's pretty similar to C, but has enough different libraries that I didn't know what I was doing. So we actually have, I pulled that up earlier. That's our Arduino sketch. It's pretty basic. The one thing that I had difficulty with is we had to process the request in a very specific way to allow cross-site scripting, which is basically exactly what we're doing, is having a request that will, from outside the server, that will do something on the server. So enabling that header seemed simple in concept, but it wasn't.
And that header is enabled in,
By the server, and how it's this part right here.
yes. Oh, it's just like a couple of print lines, right?
Yes. But in order to be able to do that, we had to completely change how we listen for responses. And so instead of just basically having a blocking call for input, that would not work. That's how they recommend you do things when you listen for a response, but for some reason that wasn't working to send the header. So what we ended up doing is polling every, I think, like maybe 50 milliseconds or something like that, and then going from there, and then responding if it receives something within that time. So to the user, it doesn't really make a difference, but we had to change the server a couple of times to get it to work.
As far as the hardware side, which is what I mostly worked on, the hardest part was definitely soldering because I've never done that before. So I borrowed my engineer roommate's equipment and got to work. And my first few were very poor, and then the rest of them were brought up to the level of mediocre. But that was definitely the hardest part was figuring out how to solder, and then soldering all three of those together was fun because it started like there were, once you got close to soldering them all, then you just were like trying to solder around all of these different wires, and it got interesting. But that was probably the hardest part hardware wise.
We also learned that you can draw too much power. We flipped a couple circuit breakers and then fried a socket before we learned our lessons.
Indeed.
But it works now.
Not the socket that we fried.
Oh no, that's still dead.
Yeah, that's very dead.
So you don't, where else do you do soldering? What other class do you have?
We
soldering?
never do.
Yeah,
DC or?
Mm-mm.
I mean, we use
Breadboards then.
breadboards, but we never had to solder anything.
Solder anything. So this wasn't exactly our first time working with the whole circuit, like working with circuits, but soldering and stuff was definitely
It was our first
new.
time working with AC power, though.
That is true.
We'd taken some classes in digital, and then DC.
Mm-hmm.
But you didn't take that at Unknown, did you?
No, we took those here.
Go ahead. How about Sam? Any lessons learned, difficult things?
Not really on my end. They worked on all the hardware and software for the most part, and I just joined in for the ride. No. But getting the group together outside of just Chris and Drew was a little bit hard. We only did that like once. Or
yeah, we did a couple of times, but
yeah.
not a ton.
So, report wise, do you have something? I mentioned last time you had something on.
Sam was working